Hello everyone, welcome to Compiler Design video series. In our previous video, I have already discussed about syntax directed translation. What is SDT? What is syntax directed? Definition, L attributed grammar, S attributed grammar, inherited attributed, different types of synthesized attributes. In this video, I will discuss about unit number 6, runtime memory management, and topics which are covered in these videos are source language issues, storage organization, and difference between static and dynamic memory allocation. So first, what is runtime memory management? A translation needs to relate the static source text of a program to the dynamic actions that must occur at runtime to implement the program. The program as a source code is a collection of text which is either your code or any statements, and to make it alive it requires action to be performed on the target machine. So your program consists of names of procedures, identifiers that require mapping with actual memory location at runtime. So runtime environment is a state of the target machine which may include environmental variable, software libraries, etc. to provide services to processes running in the system. By runtime, we mean a program in execution. Runtime environment is a state of the target machine which may include any libraries or any environmental variables. Runtime support system is a package mostly generated with the executable program itself and facilitates the process communication between the process and runtime environment. So source language issues. There are total 5 source language issues. First is procedure call, second activation tree, third control stack, fourth the scope of declaration, and fifth is binding of names. Then what is doing in procedure call? So procedure definition is a declaration that associates with an identifier with a statement. The identifier is the procedure name and the statement is the procedure body. For example, give one definition of procedure named read array. Procedure read array variable I integer begin for I equal to 1 to 8 do real a of I and procedure is AND. When a procedure name appears within a executable statement, the procedure is said to be called at that point. Second is activation tree. Activation tree is used to depict the way control enters and leaves activations. In activation tree, each node represents an activation of a procedure. The root represents the activation of the main program. The node for A is the parent of the node B if and only if control flows from activation A to B. And the node for A is to the left of the node for B if and only if the lifetime of A occurs before the lifetime of B. So in your activation tree, there is the instruction which your control enters and leaves from the activations. Next is control stack. Control stack is used to keep track of live procedure activations. The idea is to push the node for activation onto the control stack as the activation begins and to pop the node when the activation ends. Stack is used FIFO, first in, first out. So the content of the control stack are related to paths to the root of the activation tree. When any node n is at top of the stack, then the stack contains the nodes along the path from n to the root. Scope of declaration. Declaration is a syntactic construct that associates information with a name. Declaration may be explicit or implicit. Explicit declaration such as variable I, which is integer, or they may be implicit. For example, any variable name starting with I is assumed to denote an integer. The portion of the program to which declaration applies is called the scope of that declaration. Binding of names. Even if each time name is declared once in a program, the same name may denote different data objects at runtime. So the data object corresponds to a storage location that holds values. Here the term environment refers to a function that maps a name to a storage location, name to storage location, and the term state refers to a function that maps storage location to the value held at here. So name, environment, these both are same. So name to storage and storage to value. When an environment associates storage location S with a name X, we say that X is bound to S. This association is referred as a binding of X. So these 5 are source language issues: procedure call, activation tree, control stack, the scope of declaration, and binding of names. Sometimes in your GTU exam, the questions may ask like explain source language issues or explain source language issues in runtime memory management. So you have to write these 5 source language issues. Next is storage organization. There are 3 different parts in storage organization: subdivision of runtime memory, activation records, and compile time layout of local data. So subdivision of runtime memory. The compiler demands for a block of memory to operating system. Whenever you have to execute any program, at that time compiler demands a block of memory to operating system. Compiler utilize this block of memory executing the compiled program. This block of memory is called runtime storage. This runtime storage is subdivided to hold code and data such as the generated target code and data objects. So the size of generated code is fixed. So the target code occupies the determined area of the memory and compiler places the target code at end of the memory. So the amount of memory required by the data object is known at compile time. So data object also can be placed at the statically determined area of memory. It uses stack and heap. I show this memory in this figure. Stack is used to manage the active procedure. Your which procedure is active is stored in stack. Managing of active procedure means when any call occurs, then the execution of activation is interrupted and information about status of the stack is saved on the stack. So when the control returns from call, this suspended activation resumed after storing the values of relevant registers. While heap area is the area of runtime storage in which the other information is stored. For example, memory for some data items is allocated under the program control. So memory required for these data items is obtained from this heap area. So memory for some activation also called from the heap area. Next one is activation records. Various fields of activation records are temporary values or temporaries, local data, saved machine status, access control link, actual parameters and return. So first, what is activation record? Any data structure containing the important state information for a particular instance of function call may exist entirely in memory or it may be partially stored in registers. So the execution of a procedure is called its activation. An activation record contains all the necessary information required to call a procedure. An activation record may contain the following units depending upon the source language is used, like temporaries, stores temporary and immediate values of an expression. So in temporary values, the temporary variables are needed during the evaluation of expressions. Such variables are stored in the temporary field of activation record. Next is local data. In your program, local variables is the data that is local to execution process is stored in this field of activation record. Third is saved machine status. The field holds the information regarding the status of machine just before the procedure is called. This field contains the registers and program counter. Fourth is access link. This field is optional. It refers to the non-local data in other activation record. This field is also called static link field. Next is control link. This field is also optional. It points to the activation record of the calling procedure. This link is also called dynamic link. Sixth one is actual parameters. This field holds the information about the actual parameters. These actual parameters are passed to the called procedures. And last, return value. This field is used to store the result of a function call. Whenever your value is returned, at that time it's stored in return value. Next is compile time layout of local data. If your runtime storage comes in a block of continuous bytes where byte is the smallest unit of addressable memory, the amount of storage needed for a name is determined from its type. So storage for an aggregate such as an array or record must be large enough to hold all its components. The field of local data is laid out as the declaration in a procedure are examined at compile time. Variable length data has been kept outside this field. So we keep a count of the memory location that have been allocated for previous declarations. From the count, we determine a relative address of the storage for a local with respect to some position such as the beginning of the activation record. The storage layout for data objects is strongly influenced by the addressing constraints of the target machine. So these three are the storage organization. In your GTU exam, questions may ask like explain different storage organization techniques. First one is subdivision of runtime memory. Second one is activation records. And third one is compile time layout of local data. In your past, in many papers, questions are asked like what is activation record? Explain. So activation record is the most IMP questions because in your previous exams they will ask many more times. Next is differentiate static and dynamic memory allocation. Static versus dynamic memory allocation. So you have to remember these key points. These are only 7 key points. So what is static memory allocation and what is dynamic memory allocation? So first, all of you have to know what is static and what is dynamic. What is static? It is done before the execution. Then what is dynamic? It is done during the execution. So in terms of memory allocation, static memory allocation is allocated before the execution of the program begins, while dynamic memory allocation is allocated during the execution of the program. Memory deallocation. No memory allocation or deallocation actions are performed during the execution. In your static memory allocation, you can't perform any allocation or deallocation, while in dynamic memory allocation, memory bindings are established and destroyed during the execution. Third is variable. Variables remain permanently allocated, while in dynamic memory allocation, allocated only when program unit is active. In static memory allocation, it requires more space. According to space, static allocation required more memory space, while dynamic memory allocation required less memory. Because in your static allocation, first you have to declare all the variables which are used or not used, while in dynamic memory allocation, it required memory which variables are used. So it considered less memory compared to static memory allocation. According to speed, static memory allocation is faster execution than dynamic. So dynamic memory allocation is slower compared to static memory allocation. In static memory allocation, pointer is needed to accessing variables, while in dynamic memory allocation, no need of any dynamically allocated pointers. Implemented using stack and heaps in static memory allocation, while implementation using data segments in dynamic memory allocation. So these are 7 key points for static versus dynamic memory allocation. According to space, dynamic memory allocation is better. For speed, static memory allocation is faster than dynamic memory allocation, because pointer is used for accessing variables, while in dynamic allocation, no need of any pointers. So this is static versus dynamic memory allocation. So in your exam, sometimes may ask like explain static memory allocation, explain dynamic memory allocation, or explain static versus dynamic memory allocation. So in today's lecture, I discussed about source language issues. There are 5 source language issues: procedure call, activation tree, control stack, the scope of declaration, and bindings of names. Second is storage organization. There are 3 techniques: subdivision of runtime memory, activation records, and compile time layout of local data. And third one is static versus dynamic memory allocation. In your activation records, there are total 7 fields. First is temporaries, then local variables, saved machine status, access link, control link, actual parameter and return values. So in your runtime memory management, there are 3 topics we discussed. Thank you.